Good afternoon and welcome to Vector Institute's Research and Careers in AI. Today's session shines a spotlight on some of the wayfinders in artificial intelligence, with companies that have driven significant advances in AI and have captured our imaginations along the way. My name is Melissa Judd, and on behalf of everyone at Vector, thank you for spending this time with us, and a special thank you to our presenters, Google, NVIDIA, Thomson Reuters, and Uber ATG for sharing some of their work. I would also like to acknowledge and thank our funders, the Province of Ontario, the Government of Canada through the Pan-Canadian AI Strategy administered by CFAR, and industry sponsors from across the Canadian economy, including the 4 companies presenting here today. I also wanted to pause to acknowledge the land on which Vector is located here in Toronto, what is now a meeting place for many First Nations, Métis, and Inuit peoples, as well as newcomers to Canada from around the globe. The land we are situated on is the traditional territory of many nations, the Mississaugas of the New Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples. We acknowledge that Toronto is covered by Treaty 13, signed by the Mississaugas of the New Credit, and the Williams Treaty signed with multiple Mississaugas and Chippewa bands. We are grateful for being hosted on this land. Now, before I introduce our first speaker, I did want to remind everyone that today's session is being recorded, and there is an opportunity to ask questions of our speakers at the conclusion of our 4 talks. In the meantime, though, feel free to queue up your questions in the Q&A function at the bottom of the screen with your question. And of course, if it's directed at a specific panelist, please remember to include their name. Okay, our next speaker is Shohreh Shaghaghian, who is a research scientist at the Center for AI and Cognitive Computing at Thomson Reuters. Shohreh holds a PhD in electrical engineering from McGill. Her current research interests include the applications of machine learning, natural language processing, and artificial intelligence in the legal domain. As part of her role at Thomson Reuters, she incorporates state-of-the-art solutions to create tools that can facilitate different reviewing tasks for law practitioners. Please join me in welcoming Shohreh, whose intriguing talk title is the Not So Natural Language Processing AI Practices at Thomson Reuters.
Thanks, Melissa, for the introduction. So I want to, during this talk, I want to use this talk to give you an overview, a high-level insight of the products, the AI components of those products that we have at Thomson Reuters, the challenges, and the new paradigms. So when I say Thomson Reuters, most of you probably would think of Reuters News, which is it's a news service. But TR basically is working in other domains of other solutions. 2 of the most important ones are in legal and tax and accounting. So these are a list of some of the products in the legal. It's just from the TR website. You can go there and learn more about those. But basically, these products are some technology and enabled products for the legal practitioners in law firms. So based on the different countries and different regions, based on their legal system, there are different products that they can use. Similarly, for tax and accounting, the main clients are for accounting firms, corporations, financial institutes, and even governments. And you know more about the news service for broadcasters or publishers. Not all of these products have an AI component. The mission of teams like mine is to enable these products with new features, new AI-based solutions, or upgrade the existing ones. So I want to now go through some of these use cases to give you a better idea about that. So for the, in some legal systems, I think Canada is one of them as well. Courts, in making their decisions, they are limited to the decisions of past cases. So, for example, if at 2015 a judge is investigating in case 3, and there was a very similar similar issue in a case in 2011, that the judge has made a certain decision based on that. Now this at 2015, this judge has to follow the same rule, unless the Supreme Court comes in and says and overrules this issue in this case. So now let's say at 2016, this case 4 explicitly invalidates case 1. So this is an explicit expression for that. But what about these cases that had happened in the middle, like cases 2 and 3? They don't necessarily have cited case 1 for the same issue, but they may have. So there's no. So for example, if a lawyer at like 2018 is working on a case who wants to cite this case 3, in order to figure out is this issue in this case has been overruled or not, there is a need to go through a lot of documents and a lot of reading, which takes a lot of time. But this is something that can be automated with some solutions. So let's say, for example, this case A and case B have cited this case R. We want to figure out, have they cited it for the same issue? As you know, so for example, for papers, you can cite one paper because of the data set that it has used, or because of, for example, the first algorithm it has used, or the second one, or a discussion in its results. So the goal is to figure out, are they citing the same thing or not? In order to do that, you have to identify the issues in this case, come up with an embedding of these issues, and similarly identify different sections of the, for example, one of these citing cases, and based on similarity, identify which part of these cases are using these, which one of these issues, which one of these overruled issues. Once you can come up with a top candidate list, then you can go to the second case and identify which part of this case is similar, and so that you can make a decision whether it's overruled or not. So as you see, there are a lot of embedding and text similarity and classification problems here. Similar to the citation issue, when, for example, a lawyer is drafting a brief for any statement that they are making and an argument that they are making, they have to cite a valid previous case. So it's a lot of spending time on doing legal research, but we can find those citations automatically. It's just not based on text. There are certain legal features in these two cases that should match so that they can be cited. So we can come up with a search engine in like this Westlaw product. We came up with a search engine that that comes up with a best list of cases to cite. A very popular use case in most of in a lot of products is the question answering or passage retrieval. So when a lawyer is reviewing a document, let's say is a contract or a court report, there are certain pieces of information that they want to highlight. And these documents, when I say document, it can be hundreds of pages of document. So with QA and, for example, name entity recognition, there are approaches to facilitate this process. Or, for example, for tax professionals, for example, let's say they want to figure out how is the bonus depreciation different from something else. Going through this huge repository, we can come up with the specific parts of a specific documents that they can read to figure out, to find their answers. And finally, with the news domain, now we live in a world of connected eyewitnesses. Every one of us has a cell phone, and we can take pictures and videos and put on our social networks. So any news agency should be able to parse these social network content in order to cover these news. But there are two main questions that we should answer. The first one is whether this piece of news that is shared in social networks valid, or is it fake? Second one is that, is it important? Is it a cop killing a guy, or is it someone going to a restaurant sharing the picture of their food? So there are a lot of processes that should be done in this in order to figure out these two questions. First of all, filtering the noise, identifying facts, identifying whether this is a fact or is it my own opinion. And you cannot just do it based on one, for example, tweet. They should they should find the similarities, cluster them based on topics, do topic modelings. And finally, you can come up with two scores. One is the net worthiness ranking. Basically, is it important or not? And the second one is the veracity scoring. Is it valid or is it fake? And this is good statistics. It's a bit old. During this 1 year period of December 2015 to December 2016, this reports the average time it took certain sources of news to basically report about 66 breaking news stories. So they're grouped. The red one is this Reuters News Tracer. The blue one is a group of news agencies like Reuters itself or Associated Press. And the green one is the earliest global media, like, for example, BBC or CNN. So as you see, except for the expected news, and by expected news, I mean the ones that are not based on eyewitness, for example, the result of election, that they coming from one central source. Except for these ones, we see the average latency. We see that Reuters News basically is beating other sources for coming up in terms of like the delay it takes to report it. So this can be a very good assisting tool for the journalist to come up with an initial set of candidates. So probably by now you have figured out the common tests that we have. So they are mostly on like text classification, name identity recognition, question answering, passage retrieval, semantic similarity. You may ask, okay, these are very typical tasks and there are a bunch of solutions for them. And nowadays, BERT and GPT-2 and GPT-3 can do anything. That's true, but there are certain aspects of these specific domains that kind of requires some customization of all these models. So this goes back to the topic of my talk, not so natural language processing. These are my observations based on my own personal experience of working specifically. This is just based on legal domain. So when you are looking at a legal text, it's basically not similar to plain English text. That, for example, like the book corpus or the Google News or Wikipedia, that most of those general domain models have been trained on. So, for example, for the legal domain, there are some very domain-specific terms, whether they are like terms and phrases that are unique to law, or, for example, there may be legal words that have different semantics when they are used in the legal context, for example, party, title, or they can be like all words that you never, basically never hear in a generic context, or non-English words, for example, with Latin roots or French ones. In addition to the words, even the syntactic structure of the sentences can be different. So this is a very typical sentence, and it's from a real document, a real legal agreement from this source. And you see, if you want to use punctuations to find the sentence boundary, this is one sentence, but yet it is like 7 lines. And it's not just, it's long, it has a very complicated, a very complex structure. And this is very typical when you are going through legal documents. And in addition to the differences on word level and sentence level, there are also differences on document level. So this is like a court report. As you see, every piece of information has a very specific location in document. And this location is, this like template is not necessarily used by all courts in all states. So there are so many different types of these locations. And also like these documents, there may be very old hard copy documents that have been image OCR. So there are lots of noise. So sometimes it's not even just the text processing. We have to look at it as an image and find those locations, find that piece of information that we're looking for. So hopefully right now you have given an idea of the types of problems and the challenges. But I want to take a little bit time to talk about the new paradigms. You probably have heard that data is gold, but I believe that label data is completely something different that with its own cost. So we are using like domain experts that are lawyers. They are super expensive. They charge based on like 10 minutes of their time. So a great amount of effort that we do right now is based on trying to optimizing this process, optimize our use of the data, whether it's using data augmentation, whether it's coming up with a semi-supervised learning approaches, or reusing the model, for example, doing transfer learning or domain adaptation. I just want to go through some of the use cases here. So for example, let's say for you have trained a question answering model on a domain of like family law data. And you have trained one model one. Now let's say you wanted to do the same thing with similar questions, not necessarily the same, but for example, in the employment law data. Do you have to do all this effort and all this annotation costs from scratch, or can you use model one to get some insight? Can you adapt model one to this new domain? Or in another study that we did, it's basically trying some active learning approaches. Let's say we can optimize, like the question is how we can optimize our annotations effort by choosing the most important informative data samples. So the documents that we want to send for annotation, what are the most important ones? What are the smartest way to choose them? So this graph here shows the study on one of our internal tests, the F1 score versus the percentage of the data that we can use. So we see that using a very simple active learning strategy with around 33% of the entire data, we could get the same performance as using the entire data. So basically it means 1/3 of the cost that we had before. And finally, another example is like adversarial training. You have probably seen these pictures of pandas in the image domain and coming up with adversarial examples. But I believe that in the text domain, there are much less work that has been done. So for example, this is an external data from the IMDb movie reviews, and we have trained a classifier to sentiment analysis on that. You see, by choosing a very just one word from great and wonderful, which are both positive words, the sentiment has changed from positive to negative. So it means that the model that we have trained is not completely robust to this kind of perturbations. So now if we can add this second example to the data set, a training data set, we can come up with, the studies have shown that we can come up with more robust models. But specifically, for example, in the legal domain, where there are very certain and very specific certain words that you can use in any document, it is much more challenging. I hope I have given you some insights about that. Please feel free to ask me questions in the chat, or you can also send me email.
Thank you, Shohreh. It was fascinating to explore some of the different use cases of NLP across domains. Thank you.